Let's welcome Shree N. Vanaraja Sir. He is having 20 plus years of experience in instrumentation and control systems. His experience covers maintenance, erection, commissioning, projects, and design. Thank you, sir, for coming here and sharing your knowledge and experience with our community.
Okay, good evening. Thank you for giving an opportunity to discuss about knowledge sharing sessions of our instrumentation engineering. I am very much happy to participate this forum. So it's my one of the interesting subject to participate the knowledge sharing sessions. So okay, we can go ahead for your questionnaires. Whatever the information I have experience that I will share to our forum. Initial stage, I am starting with very basics. So
Okay.
in later stage, we will go for the in-depth studies or in-depth studies and knowledge sharing sessions.
Okay, sir. Thank you, sir. We prepare series of questions and we will go one by one. So the first one is, what inspired you the most in the instrumentation engineering journey for you, sir?
Okay. My first career in instrumentation engineering is started in the year of 1997 at breweries plant, which is having a CPP, captive power plant. My first assignment was in CPP, and I was hired for as a trainee engineer.
Okay.
And this plant had instruments like a pneumatic type PID controller. Okay, all maximum during that time the maximum of the instruments is pneumatic type of instruments. When I was joined, I am some after 6 months. I am observing that there are so many pneumatic controllers are there. People are going and coming, and they are doing something. Unstable position. They always operator used to tune the PID pneumatic PID controllers for stable the loop. So I asked that operator, why you are always, once in an hour or once in a 2 hour, why you are tuning the PID value, you are rotating the knob, why, what is the problem? Then he told that this PID loop is not instable. The pressure control always is continuously stable, open or close or abnormal pressures is controlling. So it's not actually our process requirement. So then, I was a fresh engineer. Then I have studied, pneumatic instruments. SLC single loop controller, telemetry systems, and at that time, small type of Honeywell DCS. These are older versions Honeywell DCS. Everything I have studied in the last sem of my studies. Then I thought on trial basis, why can't we implement one electronic single loop controller to stabilize that loop? So then I convinced my boss for budget to procure the electronic type controller. My boss background is electrical, so I have convinced him to procure the electronic type controller, and he is also agreed and he encouraged me. We installed, configured, and observed the control loop. It was very stable position it came. So after a few days, the operator told his boss, and now the pressure control is working very stable. And the same information has passed through to my boss also, and my boss came and appreciated me. Particular period, I was very excited. My excitement was very high. This is one kind of my career memorable things.
Luckily, we don't have these pneumatic type PID controllers today. They involve a lot of work.
Yes, yes. So, I mean, lot of work, and people will first, they will not have a confidence with the instrumentation department. First of all, what the operator will say that first you remove the instruments, we will see only pressure gauge. So that much frustration they will go.
Yes, the pneumatic type means the PID controller itself will very disturbing.
Yeah.
Every time
Yes,
we have
yes.
to adjust the tuning.
Correct.
So a day in the life. We want to know what is your day like in present instrumentation engineering. Right now you are in design. So what is your day like? What jobs you do and what tasks you are handling like that? We want to know.
Recently, I'm working as a project engineering team. I used to prepare the specification as per the project requirement, scope of work, then project documents like P&ID, drawings, logic diagrams, preparation logic diagram validations, and vendor management. And after completion of all the project engineering work, then we will go for FAT and SAT for the various projects at a time.
How many projects are you handling, sir, right now at a time? Only one project or more than one project?
No, actually, if you see one major project, in this project will have many packages, type mechanical packages will be there. The relevant mechanical packages, around 14 packages are there that I'm handling. And partially I used to involve the ICS systems, because I was worked as a system integrator also. So I used to participate the ICS systems, CFAT, and site activities, those kinds of things I have.
Okay. Okay, sir. We will go to the next question, sir.
Yeah.
So the key skills for success. So what skills do you believe have contributed to you, sir, for your success in this field?
Yeah, it's a good questions. It's basically one simple general word I used to tell. Everyone knows. It is actually dedications to the job and teamwork. This is my rules or slogan. So, understanding the plant concept by studying the process, IC system architectures, and relevant engineering documents. By attending the number of field problems and different type of system issues, this was eventually helped me for success in this field. So I will share one of my past experience. We were commissioning the power plant. It is a thermal power plant. We are going to synchronizing with the grid. Okay, it's
Okay.
a BHL Mac turbine. That time we were discussing about the turbine control systems operations. So we some conversation is going on. In that one of the conversation still I remember that BHL commissioning engineer, he said that we gave you the uh, turbine like baby to you. Okay. You have to take care of the baby without any disturbance. If you disturb, then more money is required for the normalization, and downtime will be unbearable. Like that, he told. So then that time I understood that system is very sensitive, and more attention have been given to to maintain the systems without tripping. To avoid the system down, referred the documents like interlocks, control philosophy, alarms, and trips in depth. So also same whatever I learned, those things I used to share to my colleagues, so it should not have any problem in the turbines occurs.
So by learning everything from start to the end, this will help us to learn the complete control system, and we'll get the grip over the plant,
Yes,
which
yes,
eventually which eventually give us success in our field.
Correct. Because always we all the times we should refer the document in the specific document. We should not think, I mean, when you come into the plant, the particular equipment and that particular equipment relevant document only needs to be read. We should not apply the external kind of things. Then it will give it will be a track changes will happen.
Okay, sir. So this next one is very interesting question. The question is from maintenance to design. Means, let's say we have maintenance engineer is having some 10 years and 15 years of experience, and he wants to move to the design field after 10 years or after 15 years. Is it possible?
Okay. It's person to person aiming will be different. Everyone will not get the opportunity to the field changeover. If
Yes.
persons wants to work for all the four fields like O&M, design, project, and the system integrator, he should change each field for every 2 years, once in beginning of career itself. Thereafter, he should select his interested field and settle down, so that career growth will be good. Of course, each field of experiences are beneficial. If you take my career, so I have I mean, I have experience in projects. I mean, my career is started from the project. My flow was there. Initially, I mean, joined as a trainee engineer, projects, erection, commissioning, and maintenance. So this kind of role I have played. That is why I can able to adapt to the any field. I can adapt to any field like project, or I can go for a system, or I can go for the maintenance.
Why I'm asking this question is means in LinkedIn, mostly one of the top question or top query which I'm receiving from many engineers, this is the question. Like they're having the maintenance experience, and after 10 years they want to shift to the design,
Okay,
and
actually
they're thinking
it's
that they want to take one course. After the course, they can handle the design.
no, after the course it's not possible, because that is entirely different subject. This is entirely different subject, because even our resume will not be selected that particular real engineering consultant, or whoever there, they will not select.
Okay, sir.
This was my observation. I can't say that they should not select. So this is my observation I was seeing, because some of the advertisement also they used to mention that whoever having a maintenance experience, you don't apply for this particular uh,
Profile.
particular post. Yes, this I
Okay.
have observed.
So the next one is about misconceptions. So we want to know that what are the major misconceptions about our department, Instrumentation and Control System Engineering?
Okay, it's absolutely incorrect. Whoever having a misconceptions about instrumentation engineering, I hope they are having a less awareness. Nowadays, see, I practically seen in my career. I was a assistant engineer. My boss was initially manager instrumentation in power plant. After that, he became a power plant manager. His background is instrumentation. So here
Yes.
where the misconceptions comes, it will not come, because the growth is there. And thereafter, I came one more plant. Their maintenance head is a instrumentation background. And one more company I have seen, background is instrumentation. He is a CEO of the company. I mean, I have worked as a maintenance lead replacement for the mechanical. I used to lead the entire. It's not like that. Instrumentation engineers is having a knowledge about mechanical, electrical, instrumentation, process, and systems. So, I mean, he is having a very good knowledge, but only thing is, whoever working in instrumentation field, they should use their skills and they have to come up.
Okay, sir. And also, one of the major misconceptions which I am hearing from the parents or engineering students who want to join the engineering, instrumentation engineering, that the instrumentation engineering group, they're having the lot of subjects. They're having the very big syllabus. They have to study very long textbooks, like that I'm hearing from certain
No,
people.
actually, okay. I want to say something. See, other disciplines, they will have a more mathematicals. If you take electrical or mechanical, but our subject is only theory. Okay, maximum will be a theory. I mean, not mathematics is not there. I will not say there is a mathematics, but the maximum we used to study the theory. So even we have studied the fluid mechanics, thermodynamics, okay, electrical measurement instruments. So like that, all and cloud program also. In recent days, I have seen cloud programs for instrumentation subject. So it's not like that. Actually, every engineer is studying all the subjects. They are touching the all the other branches subjects also. Even if you see the mechanical team, mechanical person, mechanical, they are studying the mechatronics. That means
Yes.
they are studying electronics also, correct?
Yes.
So parents no need to worry about that. I mean, instrumentation engineering is, is a very low kind of subject. It's not like that. So how your son or daughter is studying, and how they are using their skills to particular applications for their growth, that is very important. So
Okay.
persons to person,
Okay.
it will be vary.
So the next one is the rewards of engineering. So what do you find the most rewarding work in our department, in our instrumentation and control system engineering?
We can be a complete automation engineer, and we will provide a
Okay.
solutions for the industrial applications. So sensors, control systems like PLC and DCS, actuators. I mean, actuator means for valve actuators and the electrical equipments. So this is our reward, because I mean, so many equipments, so many industrial applications, so many home appliances. Everything is coming with instruments only. But people are not understanding that the developed by instrumentation. They are thinking that it will come under electric.
The project management experience. So we'd like to know how the project management skills helped you in your career for leading the INC projects, instrumentation and control system engineering projects.
Ah, okay. Earlier also I shared same message. My career has
Okay.
been started like project, erection, commissioning, and plant maintenance in one plant for 3 to 5 years. Since project starting onwards up to maintenance, I will be there. After my after next changes, again I will take same kind of same kind of plant only, like project, erection, commissioning, and plant maintenance. Thereafter, I was worked as a system integrator for 6 years. So I have learned, and I have worked a lot in the systems like PLC, DCS, commissioning in the larger network. So this is, I have a good experience. So based on the above, I got exposures in the projects like PND verification, cable laying, cable requirement. Then I can say that instruments installation as per the hookup, control systems installations, loop checks, logic checks, control philosophy checks, system design and logic development. Hence, I could be able to leading the INC projects. See, because I have, multiple experience,
Yes.
multiple, different experience in our field. So I could be able to sustain or the INC, sustain the projects. It's not only my seniors also used to help me regarding if anywhere if I'm struggling. So they will help us, and I can easily adapt the requirement.
So the next one is FAT, F-A-T, Factory Acceptance Test. So we want to know what challenges you are facing or you faced during the FAT, F-A-T.
Okay, yeah, the executing the FAT is a major milestones in any of the project. Whoever handling the project engineering. So the FAT participations will be engineering team, O&M team, and equipment manufacturer will be there. So one of the observation what I want to share is that logic was not implemented as per the process requirement, even though if you give the logic charts. So the
Okay.
system engineer understanding was somewhere incorrect. So during that time, we observed that the logic was incorrect. So I explained the required process logics and implemented. This is one kind of observation I did, and especially during testing. So switches, Ethernet switches, and all we used to test. Sometimes it has gone up to 80% of the CPU load. Then why it got a CPU 80% load? We have not integrated with the network. Then why it has gone? So then after we observed that some of the unwanted configuration we have disabled. Then thereafter we brought into the normal load. This is one kind of experience. And in FAT, so actually one of the one more issue that boolean input was there. Okay. So boolean input they will take it as a system tags, boolean 1, boolean 2, boolean 3, but we don't know what
In
what
logic.
does mean by boolean 1. So for that, what we did for easy, when we want to do the troubleshooting, we required that boolean input where from it generated. So for that, I informed to respective engineer to put the descriptions of that boolean, so that maintenance team can easily understand, and easily they can be able to do the troubleshooting.
Yes, sir. It will be very helpful, sir. Whenever we're doing
Yes.
the troubleshooting some issue or checking the logic and doing some activities, if there is no
Correct.
description, means we have to check what is the tag and we have to check the input and output, from where it is coming, from which logic it is coming, everything we have to check.
Yes.
Sometimes whenever we are in some critical stage or in some trip time, we are in some stress will be there.
Correct.
And these things will help, at the time, these things will help us during the maintenance or during the system maintenance or during the plant maintenance.
Correct. So this is the beneficial of the maintenance and this from maintenance to project. This kind of observation
Yes.
which I want to say. So and also the comparison of the project specifications. We will follow the test procedure and previous experience input. But at any cost, project teams strictly stand on that they for comply the company requirement. No compromise will be taken into the consideration. This is the FAT relevant inputs.
So the next one is, we want to hear the crucial roles played by instrumentation and control systems.
Okay, the instrumentation and control systems are playing vital role of the plant operations. That is, plant process parameters process parameter monitoring and controlling, and the operation will be automatic. This is the basic of INC. But I heard one message in Mauritius, one of the power plant is running without manpower. For starting the plant, one person will come and press the start button. By hearing, we could understand crucial roles play in the instrumentation.
The complete automation.
Yes, complete automation. It's a complete automation.
Some simple start and stop. Until unless some
Yes,
problem, the normal operation is
yes,
going on without manpower.
correct, correct. It's a very surprise, and this is actually one of my CV executives shared when we were in the project. So I was working in a power plant. At that time, my CV executive was shared. You people are doing the project engineering. So this way we required, like that he told.
So innovative solutions in projects. So can you share us some examples? Some innovative solutions are done by you or by your team.
Innovative. That is what we used to do before project engineering starts. We will do the site survey. We will discuss with O&M for existing system failure rates. Okay, if unstable systems are identified, then that will not consider for the next projects. Okay, example
Okay.
for some CPs, DCS CP controllers are failing, then if advisory notes, if we see in the OEM advisory notes, for example, they used to send the advisory notes, the failure rate. So based upon that, we will consider the next project whether the existing can be used or we have to go for the new models, new model instruments.
So that means if there is some problem with the existing model or some vendor, then those will be not considered for the next projects.
No, actually, if it is larger system, we cannot avoid the existing vendor. Only thing is existing model we will not consider. Okay.
Okay.
So we will go for the tabled versions, whichever is available. One option.
Okay.
Second option, if it is local, some small packages panel, and if they are facing the problems, then we will change the vendor itself. Vendor and I mean manufacturer itself, we will change it. So we cannot change in case immediately we cannot change the DCS vendors. So what will happen in case in case integration is to done with the existing, there we will face the problem. That is why we will use it to avoid that. But very rare case only we will change it.
Okay. Okay, sir.
And some of the on more field also in the when I was in maintenance, the plant was commissioned within a year. All the radar level transmitter replaced. The
Okay.
surprise message we received from the vendor that is absolute model. Even they are not going to supply the spares also. So
Okay.
it
Within a
was
year.
very much within a year. So
Mhm.
within a year means selection of instruments where they should see that product life cycle also. If product life cycle is not seen before installing or before procuring, so it will be a very risk for us, especially for instrumentation field, because the technologies are continuously changing. So we should
Yes.
be very cautious and carefully. We have to select the instruments, whether the product life is how long they will. It will be in the market.
Okay, sir. So the next one is challenges in the field. So what challenges do instrumentation engineers face today and how to tackle them?
In general, the incorrect use of equipment. Okay,
Okay.
incorrect use of equipment. For that, definitely they should follow the wind-up manual. They should refer the wind-up manual, which how to use the equipment. One point. Second point, incorrect diagnosis of the system failures. Okay, so this is also will misguide us to failure of the instruments. So for that also, for refer O&M manual, standard maintenance procedures, or senior guidance, or equipment history in SAP system
Okay.
or tracking sheet, whatever you have maintained. This has to be followed. And incorrectly specified instrumentation. Actually, the specification may be wrong. Finding the right suppliers. If you give the specifications, sometimes the suppliers also will take deviations. Those things also we should be very cautious. So we got to choose the right suppliers and incorrectly install the instrumentation. Many times I have seen that differential pressure transmitter under low and high, the LP tapping, HP tapping, they used to interchange. So during installation itself, people has to go and witness whether the installation is correct or not. Just these are all the points they should take care.
So the next one is collaboration with other disciplines like electrical, mechanical, process.
Okay, I understood. For successing of instrumentation engineer career, he wants to success in his career. He must follow the collaboration with other engineering discipline personnels. Okay, my experience is that I was able to resolve the maintenance issues in collaboration with electrical, chemical, and mechanical engineers. Just I will give one example. When I was working in a gas plant, in the inlet gas separator, there was a one level transmitter. It is a dry leg method. So as per the data sheets we have configured, but really the level will not be high, and it will give the level high, and it used to get the trip. So we thought that okay, calibration might be tripped, and some sensors might be failure. So then we replaced. So the for level measurement, you know very well, level is equal to height into density. So we have entered the density value of whatever mentioned in the data sheet. So our engineers, shift engineers used to go and they will replace the transmitter, or they will reconfigure or recalibrate whatever it is. It will work for 1 hour. Again, it will give the problem. So one day night I was continuously, I want to observe and I want to resolve the issues. So I stayed with that. That time I was discussing with my process senior. He's a very good experience. He's more than 30 years experience. That so this is the problem we are facing. Whether the fluid density is changing or not, we are unable to understand. Whether really it will happen or not, I was asked to that process senior. He told that yes, because of the gasifications, this density will be varied. So then thereafter I got strike it that okay, so the density is varying means then this method will not work. Then we have go for the other method. That is, we have gone for the wet leg method. So it was little bit error, but the trip will not occur. So it is literally problem was resolved because my senior process engineer only gave the suggestion that suggestion or whatever the input. It was very good input to me to resolve the issues.
Yes, sir. So it is not an instrument related issue. It is a point from the process, and we don't know about at the time. The instrument engineer may don't know about that point. So that's why
Correct.
he is thinking that there's a problem with the instrument.
Correct.
Yes, sir. This sometimes we don't know either it is an instrument related thing or process related thing. We have to understand the process also. Then only we can clear out the instrument.
Yes. Correct.
Otherwise, even though there is otherwise it is a process related point. It is 100%. Everyone will say that this is an instrumentation issue.
Correct. So if any trip occurs, if any plant abnormality comes, first they will approach the instrumentation team only. No one will go for the. When they will go to the electrical team, if totally power shutdown happen, then they will go to the electrical. Okay, if somewhere partially shutdown is happening or plant abnormalities occurs, so that time they will come straight away to instrumentation. We have to analyze the problem and we have to tell the problem. This is the problem with the process or with the mechanical or with the electrical. This kind of
Yes, sir.
situation used to happen. So for
Yes,
that,
sir.
we should not be frustrated. We should be, taken. This is one kind of job for us.
Every time we have to analyze the issue, either our
Correct.
department
This
or
is
other department.
yes, yes. This is not only a maintenance, even project also it used to happen sometimes. We
Okay.
used to
Okay,
discuss.
okay, sir.
Yeah,
That's in projects also.
projects also we used to fight. So many things. So
So,
still, if time is there, I will share so many examples.
okay. Sure, sir. We need all these things because these are not available to everyone. And even though if I am not working in projects, I may not know all those things.
Correct, correct.
So the next one is learning from failure. So sometimes we plan some things, but it may not happen as per the planning.
Correct.
So do you have any experience regarding this?
Yes, in the project, reason for delay is, two cases we can, recently we faced. One is that engineering changes. If suddenly if engineering changes comes, then a delay will be happened. So as per the said project schedule, we cannot complete. Okay, but
Okay.
this will not have a more impact, but it can be bearable because somewhere we can, we can equalize the time to achieve the project schedule. But one of the issues we faced that here, the electronic manufacturing's delay. That is, for us, we were most affected. That is semiconductor chips demand. Even all the vendors, because our instruments vendors, instrument manufacturers, they told that if you are giving today PO and we will give after some 1.5 year, 2 years, like that they told. Because of that, delay happened for us, our projects.
So the next one is work-life balance. So what is the work-life balance in our instrumentation projects and other departments?
If you see the, categories wise, here we have to see. If it is a project or system integrator, it's a little bit difficult when you are working in project. However, it's manageable, but it's based upon the project stage. If initial stage is there, there will be some free time. If it is a end stage, then you will not have a free time, or you will time management and the stress management a little bit difficulties will be there. If it's maintenance, it's easy to balance. You can plan what you want for the work and life.
So networking for career growth. What's your take, sir, on this one? What do you suggest?
Ah, yeah, it's very important to keep communicating with persons. We could understand if you have more communications or more, more network with our team or our people, so we could understand the latest information about career growth, okay, and technology growth and job opportunities and learning different technologies in the systems. So this is my experience.
Yes, so this is definitely important, sir, because we don't know every system, sir. We know only few systems.
Correct.
Let's say we are working
Right.
in one plant. We can have only few limited PLCs and DCS. We don't know every
Mm,
DCS or every PLCs in the world. So if we discuss
correct.
with
Correct.
other colleagues and other plants or other sectors,
Mm,
we will
mm.
learn something new.
Yes, yes. I recently I heard that one of the our PLC is used for the ISRO Chandrayaan.
Okay.
So
Yeah. Satellite
these
communications
are
also.
all satellite communications. So these are all we don't know. When we discuss with our team, then only we will come to know. So it's very proud of that instrumentation team. Correct. So that is why we need
Okay.
to have a communication with old colleagues or new colleagues, so whoever in our instrumentation field. So it is very useful.
Okay, sir. It is very good, sir. Using PLCs in other in ISRO and satellite communications.
Yes.
So the next one is involvement in professional organizations. So what's it, sir, like how to, what is the advantage in when you are a member of the ISA and what is the advantage of ISA following the ISA like that?
Okay. Actually, ISA, Instrumentation Society of America, it is a very good forum for us, and it's very, very, very useful. Here also, if you see, knowledge sharing session used to happen once in a week or once in a month. They will send the link to participate. That in case if you are facing any problem in your plant, that also you can share, and somebody can give the solutions for that also. So I have
Okay.
participated many of the knowledge sharing sessions. Especially my ex boss is a director of that ISA in Hyderabad. Okay, my
Okay.
sir is used to call me and you have to participate. If any, I mean, busy activities also, I will at least join, but I will not speak much. And I used to join. Then I used to hear that discussions. So it's a very good forum. And nowadays they are conducting certification courses. The
Yes, sir. Yes, sir.
price concession is also I mean for providing for ISC membership. So it's a very good
Okay.
forum. We got to utilize properly.
Okay.
That is,
Yes, sir. Certifications are very important, sir.
yes,
Nowadays,
yes.
some many
Yeah,
people are interested to do the certifications.
correct, correct, correct.
So the next one is suggestions for engineers. So based on your experience, what suggestions you can give, sir, to the graduate engineers, new engineers, or fresh engineers?
Okay. First, they focus and should attend more competitive examination during final years studies to improve their basic fundamentals, and the skills will be useful for his careers. In industry field, actually we have
Yes, sir.
subcategories. Okay, in that I
Mm.
mean in that they can choose one like operation maintenance, reliability maintenance. It will part of your O&M, and design
Yes,
engineering
sir.
or project engineering or construction and commissioning, system integrator like OEM of DCS and PLC and turbo machinery controls. So industry shall be chosen accordingly. All industries are having a instrumentation scope. Our more valuable scopes are in power, chemicals, petrochemicals, refinery, oil and gas. Okay.
Yes, sir.
So for example, if one of the engineer planning to choose the career and got the opportunity in system integrator field, so he should study the few certification course like PLC and DCS, in addition to the networking, cyber security, C, C++, and SQL. This will be useful for them when he is going to work for the system integrator field. So his growth will be very fast. And
Yes.
in case if one of the engineers planning to choose the career in O&M, so he should study the few certification course like field instruments, working principles, calibrations and testing, and basis of the PLC and DCS. Even they can study the SAP module. It is a later stage of joining because they can. I mean, they day-to-day activities. SAP is required for PM. I mean, PM for preventive maintenance schedules or corrective maintenance schedule. It may require, so he can study. So he should understand the plant process also. Who is going to the O&M. So this is one kind of suggestion. And if one of the engineer is planning to choose design engineering, so based upon the industry, he should study the applicable certification course. But certification course, I mean, based upon the industry selections. But in common, they have to study for the in tools is applicable for the any industries. It is required for the design engineers. I mean, it will be useful. In case if any engineers, I mean they got the opportunity or they are going to work in the oil and gas or refinery. So he should study the LOPA, HASOP, HASID, SIL study, and SIL validation courses. Like this kind of courses they can studies, and it will be useful for them for becoming a safety engineers. So if one of the engineers is going, I mean, he said joined as a project trainee engineer, then he should study the PMP certification course. It's not immediate in later. So mainly project is timeline to deliver the material to meet the project completion within the scheduled time. This is the basic. So in this is the different type of I mean our field how press
Yes.
engineer can be choose or selection or whatever it is. So but my suggestion, fresh engineer can choose O&M or system integrator field so that they can learn fundamental knowledge of instrumentation. Thereafter they can choose which field they want. They can go to the I mean design or project. So basic knowledge he will get from the O&M or system integrator field also, because system integrator small project they will do. Thereafter they will go to the commissioning, so they can learn something from the operation.
Yes, sir. It is very important, sir. If they learn some basics and they can handle small projects, they can handle any discipline or any category very easily.
And
First, they must have
correct,
the basics.
correct. So, and also whoever joining whichever company, it's okay, but they should always focus to work on the company requirement. Our own
Okay.
requirement they should not be. So they should always focus to the work, always focus to work on company requirement, and they
Okay,
should
sir.
adapting the new challenges and changes. They should not feel that no, I can't do it. No, they should not do this.
Okay. So the next one is theory versus practice. So how to balance the theoretical knowledge and the field experience, practical knowledge?
Hmm.
When you're working with the old system or new system or new concepts, everyone has to face this one. How to use the theory and how to go with the practical experience.
Yes, actually, knows about the fundamentals and working principles of the instrument systems, and the selection of instruments based on process and operation parameters. Okay, one point. Second point, we have to follow the OEM procedures and recommendations. And past experience is useful for identify the issues very quickly and take the remedy. Apply the basic
Okay.
fundamental theory into the field while attending the job.
I think to apply all these things, again, it will take time.
Yes, yes. It will take time, but only the thing is when he is working in field na, he should whoever comes, fresh engineers, they are having some they will have some basic theory knowledge, and they can they can understand how it works. So minimum theory they have to apply in the field. Otherwise our engineering our engineering studies is based na. So whoever studied, definitely they should apply the theory, and when they are attending the issues, so that it will be
Okay.
helpful. And
And also, whenever they learn the theory, for example, fresh engineering graduates, if they learn the theory, whenever they visit the practical instruments and if they see the usage of the instruments, they can apply and they can use their theory and basics, and they can understand this instrument in the field. What is this
correct,
instrument? What it is doing? I learned something about it. Okay, this is so I know about this. So this is the instrument. This is the instrument. It is doing this job. I already know about this.
correct,
So let's apply my concept here like that.
correct, correct. Even when the graduates who is studying third year or fourth year, when they are coming into the internship training, that time
Yes.
itself we used to give the training like this is the theory you might have studied, This is the practical. So I used to give the comparison when I was there in the maintenance. So I used to give the comparison, and I used to tell the practical and theory difference. So they will be, they used to be very happy.
So the next one is maintenance strategies. So what approaches do you recommend for the effective and efficient instrument maintenance?
But as per the OEM recommendations, instruments maintenance and spares replacements to be carried out periodically.
Okay.
Then faulty equipment, if any faulty equipment is there, that should be repaired by in-house or OEM locations with necessary test. Meaning that after repairing, repaired, it will work like that. We should not assume. We have to do the necessary test whether it is really working or not, because it was a faulty equipment. So we should keep ready for the emergency replacement purpose.
So the next one is about technical challenges. So can you share your one of the technical challenges or technical problems you faced during your maintenance or in other projects?
Okay. Again, I have. I am remembering that when I was working in the power plant, actually there is a temperature measurement element, which is installed in the turbine exhaust line. Okay, so this is maximum pressure up to, it will go to, I think 2 bar something. So when the pressure is within a 1 bar,
2 bar per pressure.
so the 1 bar pressure. So the temperature reading will be very good. Means reading will be correct, and there will not be any issues. So if it is going 1.5 or 1.7, the literally the temperature indication will be gradually varied, and it used to initiate the trip. Abnormal erratic reading it used to show, and it tripped the turbines. So it is happening, but what we did, we have removed the thermocouple and we have tested in the temperature bath, but it is working fine. So it is linearly, it is giving up to 200 degrees Celsius we have tested, and 300 degrees also we have tested, even 100, 150, whatever it is, we have tested. The linear curve is there. We have done 2 days observation, then again we put back, and in the system, same issues occurred. So that time I was a shift engineer of the power plant. So then that time when I was in shift, again it got tripped. So immediately I analyzed that the pressure variations when it got tripped. So when it goes 1.5 bar and 2 bar, it is the steam noise is a little bit more. Because of that, the thermocouple was impacting. So the noise issues, due to the noise issues, the thermocouple was the problem. So then what we did, thermocouple and thermowell both we replaced when it is a shutdown condition. So thereafter there was no issues and no trip. So this is one type of experience I want to say, that it is a different type of issue actually we faced.
Okay, sir.
I think in the thermocouple, the vac frequency test, whether it is passed or not, that we don't know. Thermowells. So time was very. Time I don't have much experience in the testing and all. So I have replaced both. Then it was working fine.
Okay. Generally, we do not see or validate the test certificates that much, sir. Whenever installing or checking the new instrument,
that is instrument. What this is the difference. That is what this is the difference of the product and maintenance. understanding now. So where
Yes, sir. Yes,
the
sir.
difference is coming. So we in the
Yes.
project we used to see the test certificate. We used to see the test certificate.
So the next one is about calibration challenges. So do you face any issues with the calibrations, instrument calibrations, or any precautions taken during the calibrations?
Yes, we used to have more precautions during calibration when custody transfer metering system. The custody transfer metering instruments it's a physical meter. It is a commercial meter. So we need to
Hmm.
ensure and follow the calibration in fourth decimal value of the measurement reading also,
It's a
because as
fourth
it is a
decimal.
commercial part. Yes.
Okay.
So
So the
here
instrument reading
and
must
also
match with the four digits.
yes, because each and every decimal will have a price impact. So in general we
Yes.
used to do that calibrations, and here we have to specific and dedicated master calibration instruments will be used for the CTM, because we will not use for
Okay.
this. If you use the CTM instruments, then I will not use for the field for other applications. So I will keep dedicated for
Okay.
the CTM, because if I'm disturbing, if something is disturbed, then it will misguide the our calibration in CTM calibration instruments. So that is mislead the problem. So we will keep dedicated for that.
So you'll have dedicated separate calibration tools for the custody transfer equipment.
Yes. Everywhere, I think, I hope everywhere they will follow it.
So the next one is about calibration and maintenance. We have industries we have a lot of instruments. So how do we track the respective instruments calibration status, and how to check whether it is followed according to the given procedures or not, and how to track these records?
Mhm. Actually, companies should have a master calibration instruments, and
Okay.
those master calibration instruments must be calibrated with the NABL or NPL accredited laboratory instruments. And those instruments shall have a traceability records. Calibration shall be done as per the scheduled frequency. Okay. Calibration reports also to be uploaded in the SAP or company portal or hard copies. Also, frequently, even if you see audit, internal audit or OSD audits, they will come and see the calibration reports first. So we have to maintain the calibration record, so that it will be very useful and very essential to maintain in the industries calibration record to be made.
So the next one is about uh, operational integrity. So how do you approach the loop checks, logic checks, and control philosophy checks in collaboration with the O&M team? Whether during the commissioning or during some new extension projects, we have to do these checks, loop checks, logic checks. And what is your approach on this one?
Okay, so in here for these questions, first we need to take the clearance from the construction team for installation of field instruments, for installation status of field instruments, cable laying and termination completion as per the project engineering. Okay, so this is the first we have to discuss with construction team and take the status one point. You go for the loop checks. So before loop checks, cable continuity checks shall be to be carried out. During that time, cable furling to be checked at field instruments, junction box, and marshalling cabinet side as per the approved loop diagram, whether it is in place or not. So if
Okay.
there is a issues, ferrule issues are there that need to be changed, because it will be helpful when it is in the maintenance, when it comes to the maintenance. and we have to call for the wind-up team. Okay, then simulate the field instruments by applying the input signal like pressure, temperature, and current, and etc. Whatever applicable. Though then we will do the 25% of the signal, 50%, 75, and 100% from the field, and monitor the value in the DCS workstation at control room. And same shall be recorded in the loop checks format. In case in between, if any punch points are observed, then same should be attended parallelly. This is a loop checks. If you go for the logic checks, before logic checks, ensure that loop checks have been completed for the particular area loops. Then only we have to call the wind-up team. Okay, keep the approved cause and effect sheet or logic sheet. So like pressure, temperature, and current, etc. Whatever applicable. So whatever the the logic sheet we have to keep. Then field instruments shall be simulated by applying the input signals like pressure, temperature, or current, whatever applicable, as per the alarm set value. First, we have to apply the signal up for alarm value. We have to monitor whether the alarm value is occurring or not. Then we have to increase the signal to the trip value. Whether the trip value is generating, trip value is occurring in the DCS, or and observe the trip is occurred. Trip means either valve close, or whether really in the field, whether really valve is closed or not, we need to ensure. And if it is valve closed, automatically we will come to know that by seeing the feedback. This is the logic checks, and we have to maintain the logic record, and if any punch points are there, then we have to be attended. And if you go for the control philosophy checks, before control philosophy checks, ensure that loop checks have been completed for the particular area loops, like transmitters and control valve stroke checks, whether it is completed or not, we should be ensured. Then call for the wind-up team, keep the approved control philosophy documents. Then simple PID loops is there. Then as per the control philosophy, whether the control loop is opening, closing is happening, whether the operations, reverse operation or forward operation is happening properly or not, that we should ensure. And we have to keep control philosophy checks records also. If any observation is there, that need to be attended. This is the basics of.
And these usually takes a lot of time.
Yeah, it will take lot of time. It will take lot of time before taking into the process. This test must to be carried out.
Yes, sir. Yes, sir. So the next one is designing integrated systems, sir. So what are the important key factors during the design, sir, when it is about the integration of different systems like DCS, ESD?
Okay, I understood. Okay, here during design basis, before what we will do the studies like LOPA, layer of protection analysis, shall be followed. HAZID, hazard identification, and HAZOP study, hazardous and operability studies shall be conducted, and the SHIL study requirements to be done. Then selection and specification of control systems, control system to be very carefully examined. Then segregation for the IOs for DCS, ESD, and FGS for integration. These are all the main point for design basis key factors. Okay, especially for ICS. Based upon this output only, which type of systems we are going to install. That we will arrive this based upon these studies only. Then during implementation basis, in case if we have to do the SIL, still and we have to strictly adhere the statutory compliant requirements pre-start of the plant system audit conducting with third-party agencies and check sheets. If we need to be prepare one check sheet for the implementation, so that check sheets also to be followed.
Okay. So this design at design stage, it is very, very important to include each and every point. So you'll not get any. Sometimes in
Yes,
maintenance, if you see, we will discuss that why this is given or why this is left out. This can be a better system. This can be a better integration, so that we will have less problems during the field maintenance like that.
Yes. You see, whatever the equipment they have installed, for that some basis will be there definitely. Without
Yes.
any basis, they will not install the equipment in the plant. Okay, unnecessary implementation will not be there because so many studies used to happen. So thereafter they will conclude, okay, for achieving this, for achieving the production, for achieving the safety, for achieving the, protecting the environment, for that we need to consider, we need to study those kind of, I mean, those kind of studies need to be done.
Okay. Okay, sir. So the next one is about instrument selection, sir. So what factors or what approaches you followed, sir, during the instrument selection and sizing during the projects?
Okay. Okay. So here, first we should understand the process requirement. So if process requirement, then only we can go for the procurement for the instruments. Okay. So,
Okay.
and for example, I will tell you, the process requirement is to measure the flow in the slurry pipeline. Okay.
Okay.
So instrumentation, what we required, the process parameters we required like pressure, temperature, viscosity, density, and flow rate. Okay, these are all required. So if these parameters we will collect from the process. Okay, the pressure means it's not operating pressure, minimum, max, and normal. Temperature also minimum, max, normal. Viscosity will be a constant and density will be a constant. That value they should give. So flow is minimum, normal, and max. These kind of parameters we need to collect from the process. Then we will go for the more procurement, or we will generate the scope of work, and we will place the PO to respective manufacturer. So in case here I am example, I took that slurry in the slurry pipeline. We want to measure the flow. So we have taken the process parameters from the process. Then we have made one scope of work, and we shared to manufacturer, and manufacturer to give the, to procure the flow meters. Then meantime, what we will do, field to DCS connectivity. So we spare channels need to be identified. Okay, and wiring details. So wiring details to be marked up, and hookup of the instruments, how we can do whatever the necessary installation accessories are available or not. These things and all we need to survey, and if once flow meter comes, we have to install, and immediately we can hook up, and we will hand over to process. This is the basic, small, very, very simple basics I shared.
Okay. Okay, sir. So the next one is about troubleshooting control systems, sir. So what strategies are recommended or useful for troubleshooting and identifying the problems within the control system, sir?
Okay. See, observations. First, what you do, the for instrumentation person is required to do the observations of behavior of the system's functionality in the field.
Yes.
The field means
Yes,
either control room or field, based upon the problems where it is occurred. Then discuss with the respective operation persons and team members. Why I am telling that respective operation persons means whoever in shift, they only give the they only might have give the complaints. This system is not working. Then you have to ask
Yes.
cross questions when it is occurred, how it was, when it was occurred, when what activities were doing that time it was occurred. These kind of questions need to be asked. Okay, with the team members and operation persons also. Team members means whoever with some other engineers will be there, shift engineers or whatever shift instrumentations, whoever there.
Yes, sir.
And we have to do the retrieve the alarm history and trends from the systems. Then previous maintenance history we have to see for the particular
Okay.
equipment. And whatever the lessons learned, we have, whether that is implemented or not, that we have to see. So this is the basic tips for the troubleshooting of malfunction control systems. One example I want to tell. One of the company on PLC systems, on PLC network system connectivity, redundancy connectivity is there as per the scope, as per the our operation
Design.
requirement. It was a redundancy network. So
Okay.
the redundancy network, what happened? They did actually redundancy cable A and B. They are connected in one switch. Okay, that we don't know before doing the maintenance. After commissioning of the handover, then we are going for the first preventive maintenance. We thought that okay, A switch is healthy, then A switch and B switch, and now we thought that B is healthy, then we will go for the A switch maintenance. So
Okay.
we switch off the A switch, then network connectivity, because of the network failure, then plant got tripped. So then
Okay.
thereafter we came to know that okay, both the network cable is connected in the one switch. So
Yes.
this is actually a lesson learned. So it is after commissioning, it was first maintenance. It was it was occurred. So this is a lessons learned point, I want to say it. So
Yes, sir. We
when
can,
we do the
in commissioning only, we have to check all the cables and all the routings and all the labels, ferrules, everything is as per the design or not.
correct. So this
Even
is
the external
one
cables or
kind of
internal
lessons
cables.
learned. Correct.
Yes, sir.
So this was the problem we faced. Mm,
So the next one
So
is about lessons from failure analysis. So what's your most challenging experience in the conducting the root cause analysis, sir?
it's a very, very good, interesting subject. So for failure analysis, conducting a thorough investigation that identifies root causes will help to prevent similar events from the happening again. In this way, we can reduce the equipment failure and damage the environment. So this is the basic definition of that. And the root cause analysis methodology, if you see, first how we have to do, define the problem, collect the data, identify the causal factors, identify root causes, implement solutions. Then implement the solutions as per the recommendations what they have committee has recommended. This is the basic methodology we have to follow. And the second methodology we have, Wishbone diagram. In oil and gas, we used to say that Wishbone diagram. That is also, I followed when we were in, one of the plant. So that is also good for, identification of the fault analysis. Fault. So one example I want to share. In my career, I faced most of the challenges in electrical and instrumentation interfacing. Okay, it's a little bit complex of systems. Example: one of the electrical equipment started without initiating the start command from the field or control.
Oh,
So
okay.
while retrieving the event data of switchgear relays and event data of the system, event time was not matched for both of the systems. It's a different timings.
Okay.
This is used to impact to identify which cause is first occurred. To overcome
Obviously.
these issues, what we did, yes, we don't know. We are fighting with a team. We are fighting each other. So then, what we did, and to overcome these issues, we configured loop returning alarm to the DCS, so that if any signal goes from the DCS or field, it will go and it will return to the DCS, so that it can be we can be able to identify that this signal has gone from the DCS. So like that we have did some modifications.
So the next one is about control system logic modification, sir. So what are the key considerations we have to keep in our mind whenever we're going to do the control system logic modifications in a PLC or DCS system?
Okay. If you see the logic modifications is coming, it has to come from the MOC format. That is basically it's a MOC format means management of change committee recommendations, and it will have a competent authority approval for the that particular logic changes. Okay. So before
Okay.
doing the logic modifications, first we should ensure that MOC as given by the committee recommendation or not. That we will ensure it. Okay. After that,
Okay.
thereafter only they will issue the permit. Before issuing the permit, again we need to prepare the risk and mitigation matrix. Then only we can go for the logic modification. So modified logics shall be validated, tested in training setup or emulator
Okay.
mode. It has to be done.
Mm.
Pre-checks has to be done. So then only real implementation has to be enabled. Okay. For
Mm.
both the activities, standard check sheets to be made or to be in place,
Yes, sir.
and it needs to be followed.
So the next one is about supporting construction phases. So during construction, we have to, we will generally, people will provide some support to the construction team or they will take some start feedback from the construction team. So what is your take on this, sir?
Here, first of all, we want to give the approved as build drawings like P&ID, instrument index, instrument hookup, tray layout, building layout, GA drawing of control panels, then cable and wiring details should be shared. This is the first activities. Second, when we completion of these activities, then we have to support to the construction team for power up the panel. Even when it is coming after completion of these activities, construction and project team will be combined to do the loop checks. So they will participate both the way. Project team also
Okay.
involves in the loop checks, power on checks, and even construction team also will participate these activities. So this is based upon the situations we will share and we will do the activities, combined activities. It is basically combined activities.
Okay. Okay, sir. So looking ahead, so what are your expectations in future developments in our instrumentation engineering?
Okay. According to the industrial statics, the demand for qualified control and instrumentation is expected to grow in the next decade. It seems.
Okay.
Okay. This means that there will be a plenty of job openings in industries like the oil and gas manufacturing plant or chemical plant, power generation and automations. And also, yeah, few capability enhancement also is there for instrumentation engineers, like Internet of Things (IoT), industrial Internet of Things (IIoT), and we can say artificial intelligence and data analytics also. So these are
Okay.
all, future development for the instruments, it seems.
So the next one is the mentorship's value, sir. So how has mentorship shaped your career, sir? Means what advantage you gain from your mentorship from your seniors?
Okay. Mentor. Yes, yes. Mentor used to give the very good and relevant tips for improving the technical skills. Okay.
Okay.
For improving the system knowledge, my mentor has given many opportunities to work on the new small projects. Okay, and one time given even abroad opportunities for working in the new projects to learn the latest technology in the
Okay.
automation at the time. So
Okay. Okay.
mentor mentees program normally very useful programs only, because they also will have a target and we also will have a target. So by that we have to utilize that is important.
Okay. Okay, sir. So this is the last one, sir. So what's your guidance for aspiring engineers?
Aspiring engineers, the future of instrumentation and control engineers looks promising as automation and control systems so continue to play a crucial role in various industries such as manufacturing, energy. With the advancement of technology, there will be increasing demand for the engineers who can design, implement, and maintain sophisticated control systems, as well as integrate them with data analytics and artificial intelligence. So, additionally, as industries continues to focus on efficiency, safety, and sustainability, instrumentation and control engineers will play a key role in developing and implementing innovative solutions. Continuous learning and staying updated with the latest technology will be important for the professionals in this field.
Okay, sir. Thank you very much, sir, for sharing your knowledge and experiences with us today. And we benefited a lot from your experiences. Thank you, sir. Thank you.
Okay, thank you. I'm also, refreshed my mind, and it is very good opportunity to me to discuss with you. So it's a very good opportunity. Again, I will thank to you and our forum. Thank you.
Thank you, sir. Definitely, we will have another meeting with more interesting concepts and mostly about the basics and the theory about the instruments.
Sure. If any, if any mistakes message if I give, anybody can correct, and that also I will correct it. So no problem.
Yes, sir. They
So
can give their inputs also, sir. They can also share their
yes,
inputs through the comments.
correct. So that also I will take for my future reference. It will be very good for me. So thank you.
Yes, sir. This is the first video we recorded and done this interaction, and hopefully we will improve the quality and discussions also in the next coming videos.
Sure. Okay. Thank you. All the very best.
Thank you, sir. Thank you. Thank you for your support.
Thank you.